Welcome to the System Design Framework channel, where we simplify complex system designs and turn them into easy-to-follow step-by-step guides. In the previous video, we explored the system and user flow, which is all about understanding how users interact with our platform and how the system processes their actions behind the scenes. We broke down every step, from a user clicking a button to the system responding, ensuring a seamless and efficient experience. If you missed that video, don't worry. You can find links to all the videos in this playlist right in the video description below. In this video, we'll talk about the nuts and bolts of scaling a social media platform. We'll dive into the calculations, considerations, and strategies to ensure everything runs smoothly, even as the platform grows. Before we start, note that the numbers referenced in this video are hypothetical. Actual figures in a real-world scenario may vary depending on the system, user growth, and user interaction volume. First, let's start with the basics. Imagine a platform with 1 million active users. Out of these, about 20% are daily active users. That's 200,000 people logging in every day. On average, each user performs 5 actions daily, like posting, liking, commenting, messaging, or following someone. Here's how those actions break down: 40% post content, 60% like and comment, 30% send direct messages, 50% follow or unfollow users. And for the less frequent activities, 10% register or set up profiles, 5% update their profiles, 1% report content. Oh, and a whopping 90% log out, because, well, everyone logs out at some point. Now, here's an exciting detail. This platform grows at a steady 5% per month. Plus, 20% of the actions are time-sensitive, like likes, posts, or messages, so we need to handle them in real time. And don't forget peak traffic. Imagine traffic spikes doubling the usual activity during certain hours. It's like rush hour, but online. Okay, let's tackle storage. Every action a user takes generates about 4 kilobytes of data. That includes metadata, like user IDs and timestamps, content like posts or comments, and logs to track activities. With 200,000 actions daily, we're looking at 800 GB of data daily, 24 TB per month, and a whopping 288 TB annually. To keep this data safe, we'll use a 3x redundancy strategy, so multiply that by 3. And we're up to 864 TB per year. Now, here's the smart part. After a year, older data like posts or messages will be archived, cutting down active storage by 30%. Now let's talk servers, starting with API servers. We're handling 1 million requests daily, and during peak traffic, that's about 2,777 requests per minute. Each server can handle 250 requests per second, so we'll start with 4 servers and use auto-scaling to add more during traffic spikes. For future growth, we'll add 1 new server for every 500,000 additional users. For notifications, we'll need email servers like Amazon's Simple Email service for sending 500,000 emails daily, SMS servers like Twilio for 250,000 texts daily, and push notifications through Firebase for 100,000 alerts daily. Databases are next, with 864 TB of data annually. We'll start with 2 primary servers and 2 replicas. We'll optimize the database with indexing and partitioning for faster lookups and add more replicas as we grow. And of course, we'll need some extra infrastructure to keep everything running smoothly, at least 2 load balancers to distribute traffic and ensure zero downtime, with redundancy for failover. For caches, we will start with 2 instances of Redis or Memcached, scaling up as needed based on user growth and activity volume. Also, 1 reliable content delivery network provider for delivering static content like images and videos efficiently to global users. Finally, a scalable solution like AWS S3 or Google Cloud Storage, capable of handling daily uploads and lifecycle management for large media files. Start with 1 primary storage bucket, expanding as the media library grows. This setup ensures high availability, speed, and cost-effectiveness as the platform scales. And that wraps up this step in the system design of a social media platform. we've covered the system scaling calculations for a social media platform. Remember, if you want a deeper dive into this step, or want to explore all the other steps in detail, just head over to www.systemdesignframework.com. It's all there. And it's completely free. In the next video, we'll take things further and explore the next step in designing a social media platform. Trust me, you don't want to miss it. Hit that subscribe button and turn on notifications, so you're the first to know when it's live. See you there.